Students, now let's proceed ahead to understand the centroid of a circle. Now, if I draw a circle with respect to the x and the y axis, I'm going to take the circle again entirely in the first quadrant. So let's draw a circle in the first quadrant. So I take the x-axis, which becomes a tangent, isn't it? So the x-axis becomes a tangent. Again, let's draw the y-axis also. It also becomes the tangent to the circle. So let's take the origin here. This is the y-axis, and you can easily observe that a circle is a symmetrical diagram, isn't it? I can draw a horizontal line of symmetry, which is the diameter, isn't it? And I can draw a vertical line of symmetry, which is again the diameter of the circle. So I have the two lines of symmetry for this particular diagram, the circle. So I know that the centroid definitely has to lie on the lines of symmetry. Now, do you recall when we have seen the triangle? Was a triangle a symmetrical diagram? If I take a right angle triangle, students, even if I take an isosceles triangle, only then it will have a line of symmetry, isn't it? Only one line of symmetry is going to be possible. If I take an equilateral triangle, then there will be three lines of symmetry. So here, for a circle, we can have two lines of symmetry, students. But if I take a scalene triangle, you can easily observe that a scalene triangle will not have any particular line of symmetry. That means there can be standard shapes without line of symmetry also. So here, the two lines of symmetry are intersecting. They will be intersecting at the center of the circle, and that center will become the centroid of the circle. Students, you can easily understand that x bar is going to be the radius and y bar is also going to be the radius. Then the centroid will have coordinates r, r, and we know that the area of a circle is simply given by the formula pi r square, isn't it? Then x bar value is r, y bar value is also r. Now students, if I shift the x and the y axis along the line of symmetry, so if I draw the circle one more time over here and I shift the x axis and the y axis along the line of symmetry, then what will happen? The coordinates of the centroid will become 0, 0. So it all depends where have you kept the x and the y axis. So always remember, if you want to tell the coordinates of the centroid, you see what is its distance from the y axis, that becomes the x coordinate, and you see the distance of the same centroid from the x axis, that becomes the y coordinate. So here we have understood how to find the centroid of a circle. Students, once you have understood how to find the centroid of a circle, now we want to proceed ahead to understand the concept, or I can say the centroid of a semicircle. Students, now that you have understood the concept of finding the centroid of a circle, now let's proceed ahead to understand the centroid of a semicircle. Students, I'm going to draw a semicircle in such a way that its diameter will be taken along the x-axis. And you can understand that for a semicircle, there can be one line of symmetry, isn't it? So let's draw a semicircle over here. I will take the diameter of the semicircle on the x-axis, and you can have the y-axis directly along the line of symmetry. You can observe that this particular diagram, the semicircle, has only one line of symmetry, isn't it? And that is the y-axis. So I can say y-axis is the line of symmetry. Now students, I always know that the centroid is definitely going to lie on the line of symmetry, isn't it? So the centroid is definitely going to lie on the y-axis somewhere. Now this is another very important concept about the centroid of a semicircle you want to remember. As in a triangle, when we talked about the right angle triangle, we remember that the centroid always lies at 1/3 distance, isn't it? It always lies at 1/3 distance from the perpendicular sides. So here here also you got to remember a note while studying the centroid of a semicircle. Do not try to mug up the formula. You remember the technique. The technique says that the centroid definitely lies on the line of symmetry. So you draw the line of symmetry first, and then the centroid is going to lie at a distance of 4r upon 3 pi from the diameter of the semicircle. Students, you can see the semicircle, you can see the diameter. I have taken the diameter along the x-axis, isn't it? So this is the diameter. And as I said, that the centroid is going to lie along the line of symmetry at a distance of 4r upon 3 pi from the diameter. So here is the centroid, say G, then its distance from the diameter is going to be 4r upon 3 pi. Now students, since the centroid lies on the y-axis, the centroid is lying on the y-axis, that means its x-coordinate is going to be 0 and the y-coordinate has come 4r upon 3 pi. So students, let's very quickly write the three important concepts. The first one is the area of a semicircle. So area of a semicircle is going to be half of the area of the circle. So that's pi r square upon 2. Then I asked you about x bar. Since the centroid directly lies on the line of symmetry, which is the y-axis, x bar is going to be 0, and y bar, centroid will always be at a distance of 4r upon 3 pi from the diameter. So I can say y bar is 4r upon 3 pi. Now students, I'm going to change this diagram a little bit. Observe carefully. We are talking about a semicircle, isn't it? We have seen the centroid of a circle. Now we are looking at the centroid of a semicircle. So I'm going to change the diagram. Suppose now I take the semicircle, something like this. Now, is this semicircle still symmetric? Yes, students, the semicircle is still symmetric. So I can draw the line of symmetry and I can take the x-axis directly on the line of symmetry, isn't it? Let us take the x-axis directly on the line of symmetry, and students, I will take the diameter of the semicircle as the y-axis. So this is the y-axis. This is the diameter of the semicircle, isn't it? Obviously, O, which is the origin, becomes the center of the semicircle. So again, students, area is definitely going to be pi r square upon 2. And as I said, the centroid always lies on the line of symmetry. So here it is going to lie on the x-axis, and it is always at a distance of 4r upon 3 pi, isn't it? It is always at a distance of 4r upon 3 pi from the diameter. So this is the diameter. So from here you take the centroid at a distance of 4r upon 3 pi. So I locate the centroid G over here. This distance is going to be 4r upon 3 pi. So students, can you now guess what are the coordinates of the centroid? Can you see that the centroid is lying on the x-axis? Whenever a point lies on the x-axis, its y-coordinate is going to be 0. So I take the y-coordinate as 0, and I can easily understand that the x-coordinate is going to be 4r upon 3 pi. So let's take here the x-coordinate as 4r upon 3 pi. The centroid always at distance of 4r by 3 pi from the diameter of the semicircle. So here you have got the coordinates of the centroid for a semicircle whose position was vertical. Now students, I can take some more examples like this. Always stick to the basic concept. If I take one more diagram this time where the semicircle is kept entirely in the first quadrant. So I take x-axis and I take the y-axis. So look at this diagram at this moment. So here again I can draw the line of symmetry. So let's draw the line of symmetry. So this time line of symmetry is not the x-axis, it is a line parallel to the x-axis. So this is the line of symmetry. This is a diameter which is lying on the y-axis, isn't it? That's the origin over here. So at this moment, the center of the semicircle is not at the origin. So here I want to tell the centroid G. Centroid will always be at a distance of 4r upon 3 pi from the diameter. centroid will always be at a distance of 4r upon 3 pi from the diameter of the semicircle. So students, G over here, I want to tell the x and the y coordinates. So you can observe that the x coordinate is nothing but a distance from the y axis, which is the diameter, isn't it? So it is going to be what? 4r upon 3 pi. So the x coordinate becomes 4r upon 3 pi. And students, the y coordinate is going to be the distance of the centroid from the x axis. So this is the x axis, and I want to tell the distance of the centroid from the x axis. So this is going to be what? It is going to be equal to the radius of the semicircle. So that's the radius, isn't it? So I can say y bar is going to be the radius of the semicircle. So I write the coordinates of the centroid as 4r upon 3 pi comma r. Observe carefully, I have kept the entire semicircle vertical direction in the first quadrant. Students, I can discuss one more last case. So here I draw the semicircle again in the first quadrant, but in the horizontal direction. So that's the semicircle, isn't it? So again, can you have a line of symmetry, students? That's the line of symmetry. Then I can certainly say that the centroid is going to lie on the line of symmetry. So I take the centroid G over here. This time, this is the x bar and this distance is y bar. You can easily understand that x bar is going to be radius and y bar is going to be 4r upon 3 pi. Every single time the area of the semicircle is going to be what? It is going to be half of pi r square. But you got to properly locate the centroid of the semicircle. Just remember one concept, that the centroid will always lie at a distance of 4r upon 3 pi from the diameter of the semicircle. So students, that was all about the centroid of a semicircle. Now let's proceed ahead with the next concept, where we are going to understand the centroid of a quarter circle.